So this is the diagram that we've been looking at. This is the exact environment that we have with the 3-tier app. Now, I'm assuming that you have your vSphere, vSphere 6 installed and configured, and your hypervisors are already there. And now we're at the stage where we're installing or configuring the NSX and SRM pieces. So you start with installing NSX, SRM, and vSphere replication. So with NSX, with the cross VC, in my environment, I have 2 NSX managers, and there's a one-to-one mapping, so you have 2 VCs at those 2 sites where the NSX is mapped. The 2 sites have their own compute environments. As you can see that I have edge and compute clusters with the 6.2. You can see that the roles are very clearly defined, primary, secondary. You can have up to 7 secondaries, so it's going to be like that. In my setup, I'm just using 2 sites, right? So moving on, now I have the universal logical switches. We already talked about it. Logical switch lets you stretch your L2 across within a site. Universal logical switch lets you stretch your L2 across 8 sites. 192.168.10.0 subnet can exist simultaneously across 8 sites. As simple as that. So that's what universal logical switch gets you. And I have my 3-tier app on 3 universal logical switches, web, app, and DB. And I have transit logical switches, which is where the logical router and edge gateway are doing route advertisement and adjacency. Now, once you configure this on NSX side, you'd be like, okay, what did it do to my vSphere side, right? The view that I'm used to of. Let's go and look at the DVSs. So as you can see, it created the port groups, and so for each logical switch, a port group is created. And as you can see here, the port group names are exactly the same at both sites. So as SRM, the way I look at it, that one of the pain points previously was that you had to have this mapping. You know, my VLAN 1010 is port group this, and VLAN 1020 port group this at this side, and you have that like a cheat sheet or Excel sheet with all the mapping, and then it makes it prone to error or fat fingering or misconfiguration. With this, it's almost foolproof. Unless you actually want to map to something else, this is done automatically for you, less administrative overhead and free of error. Now, going back to our initial setup, what I have so far done. So I created NSX managers, prepared the cluster, got the logical switches. Okay, so that's where I'm at already. So now let's build on top of it. So the next step I'm going to do is the routing entities. So as we talked about, there are 2 types of routing entities at NSX, one for east-west, one for north-south. East-west is your DLR. So that's the first thing that I'm deploying. You create that at the primary side, which has the read-write copy, and it will show up at the secondary side as a read-only copy. So the DLR config has 2 pieces, one which is global, like what logical switches are attached, what's the syslog server, and you know those kind of global configuration, which lives at the primary side. And the secondary sites, all the secondary sites have some site local information. For example, the OSPF neighbor relationship, or what's the protocol address or forwarding address. Those are site local stuff, right? So that doesn't have to live at primary. That's site local, so those will be configured at the specific sites. So once I have the distributed logical router, then I created my edge services gateway. So at this time, I have 2 edge services gateway at 2 sites which are independent, and they'll be peering locally with the control VMs at each site. So now what I have is after deploying the control VMs at 2 sites, I have this configuration for each site, the protected and recovery site with their own local routing configuration. And now, once I've, so far I've built the infrastructure, I've built the routing entities. What about the firewall? So in 6.2, your firewall rules have the capability of being universally synchronized. So what that means is as soon as I create a firewall rule and I mark it for universal synchronization, which is done at a section level, so all the rules in that section are marked for universal synchronization, all the hosts and all the sites will get these rule sets. So you can control what VMs you want to be universally synchronized versus locally synchronized. In the demo, what I have done is I have simple rules, and I'm going to be logging into the application VM, pinging the web and DB tier. The web tier should not work, and the DB tier should be accessible from the app. And we'll do this test in different scenarios to see how the security posture stays same across the different scenarios. So going back to our setup, we were at the logical switch. We deployed the logical router, the control VMs, the edge entities. So at this point, my NSX configuration is done, right? Now let's look at SRM. So SRM config is pretty straightforward. You have the sites paired, and this is how the network mapping look like. And this is something you guys are would be pretty familiar with. But now here you can see that this mapping is done automatically for you. You have the option to make changes, but you don't necessarily have to. And one thing that I guess I would love if I was an SRM administrator is no IP customization rules needed, because the same IP lives on both sites, right?
So just one point on that. So while those logical switches exist on each side, that's the only thing that is new in that is new from this design perspective that comes in that comes in SRM 6.1, which is basically this mapping. But again, if you're using NSX, those things will already exist, so you don't need automatic mapping.
Cool, thanks. Yeah. So I have two protection group, one for database and one for web and app, and I have respective configuration done for the recovery plan, and the clarity in the configuration is such that I know when the thing fail over, where it's going to land and what port group and everything. So now before I start the demo, I want to show, so we've been looking at the logical design yet, right? Now let's look at the physical design. So this is how physically the same thing is set up. So what I've tried to do here is I've kind of trimmed it down and slimmed it down to the bare bone basic stuff that you need to get this thing working. And I want to do this so that we pronounce and show the key features that you're here for to look at. But in production, you're not necessarily going to have exactly the same. For example, right now I have one edge services gateway each side. In production, you'll have ECMP or high availability HA. So that would be your normal scenario. And another thing that I've done, as we mentioned before, I've set the interface in disabled state. So that means I'm not sending any routes from the recovery site. So let's go ahead and look at the demo and how it actually looks like. So I'm logged into my environment here. So first, let's start by looking at the routing entities. So I'm going to log into the protected site, top of the rack switch, and look at the routes there. So here, .198 is my edge services gateway, and as you can see that it's advertising all the routes. .0, .8, .16 is my 3-tier app. All of those routes are being advertised to the top of the rack right now. So this is what the top of the rack is learning. Now, if we go and look at the recovery side top of the rack, as the edge services gateway is in disabled state, it's not going to be sending any routes, and .86, as you can see here, is not advertising any routes out. So I'm hard controlling my routing at this point. But if I look at the edge services gateway protected sites, you can see that it's learning routes from the universal logical router. And at the bottom, I have a packet capture running now, and I'm capturing on the web VM traffic. So as soon as the traffic starts coming in here, we'll see the packet showing up, right? So before we move on, let's see if the application is accessible and we see the packets. So this is my web application, which is accessing the database and the app tier in the back end. As you can see, the application is accessible, and I can get to it. Let's see the packets. And as you saw, the packets are coming in. That means everything is coming in and out of the protected site at this point. Now, before moving on, the last thing I want to show you here is the firewall rules. So I'm logged into the application VM, and I'm trying to get to web, which should not be accessible. And then I'm going to try to get to the database tier, which should be accessible. So that means at point 0, where everything is normally working from the protected site, my firewall rules are applicable. My application is accessible north-south. Now, the next thing I'm going to do is what we talked about, is move the web and app over. So let's see how that works. So this is my environment. As you can see, the web app and DB are running at the protected side, and at the recovery side, we have the placeholder VMs created, and there's no network or disk attached, as you would expect with the SRM. All right, so now let's go ahead and kickstart the failover, and I'm going to move the web and app tier from the protected side to the recovery side. So at this point, when this happens, the application has moved over, the VMs have moved over, but I haven't touched anything from the networking aspects. No routers touched, no firewall touched, and not even from NSX aspects, I'm not touching anything. So fast forwarding, the test is now complete. And if we just quickly revisit our diagram, we'll see that the traffic has moved over. So you had the app and web on the left side, and you moved it over, and traffic just followed the web VM on the other side, and east-west continued to work. So zero touch, now that's working. And if I look, you can see the web and app are stopped, and they're running at the recovery side. I'm not cheating with you guys, right? So let's see, after moving over, if the application is still accessible. That pays our paycheck, right? So application is still accessible. Yeah, it is. So perfect. So this is good. Where are the packets coming in? I'm at the top of the rack, Edge Services Gateway, the protected side, and I see new packets coming in. So my traffic is still flowing where I'm expecting it to flow. What happened to my firewall rules? I'm logged into the app and VM again, and I try to get to the web and DB, and my rules are still being applied as they were before. So again, application moved over, no changes needed on the network side, firewall rules are still being applied. So at this point, I'm all done with my partial failover. Now the last thing I'm going to show you is the complete application failover. So at this point, let's say your application was on the protected side, you want to move it over the recovery side, and you also want to ingress and egress out of the recovery side, because that's also what you want to see, right? That can you actually do it, and how painful would it be? So for this demo's purpose, what I'm doing is I'm dropping the Edge Services Gateway at the protected side, so no routes will be advertised out this side. And then the application moves over, the locale ID gets set, and the interface is enabled. Once that happens, the OSPF neighbor relationship comes up, and the packets start going in and out of the recovery side. So now let's actually see it working. So let's go ahead and do it to the database tier. So one thing is, like in normal circumstances, you're going to be failing over a bunch of VMs, and the time that it will take for the VMs to actually power up at the recovery side is going to be good enough to run a couple of API calls. And I'm going to show you how you can run the API calls to change the locale ID and enable the Edge Services Gateway interface. And I'm only going to show you for the locale ID, but it's the same idea. It's just one API call. So now the DB VMs have moved over. I'm using here a simple REST API client, and I'm pointing it to a cluster. If you see, there's as simple as it can get sort of API call. This is your locale ID we've been talking about. This is what it is. It's just that one string, and then you push it across to your clusters. So once this is done, your locale ID is set, and in the meantime, I've enabled the Edge Services Gateway interface. As you can see, the 3-tier app is now running at the recovery side, and nothing is running at the protected side. If I go back and have a look at the Edge Services Gateway at the recovery side, I see the new neighbor relationship coming up, and the routes being learned from the UDLR and the top of the rack as well. And at the bottom, I have a similar web packet capture running, so to see if the packets are actually coming in and out of the recovery site. All right, so at this point, let's go ahead and see if our application is still accessible when everything has moved over. So I do a shift refresh, and voila, the application is accessible. The packets are coming in from the recovery side. I don't have any new packets coming in from the protected site because the edge services gateway is literally dead. And at the protected site, at the recovery site top of the rack, it was not learning any routes from the edge services gateway before, but after the failover and enabling just one interface, you see that it's now learning the 3-tier app. So with 2 API calls, essentially, you've moved your all application, the whole tier, and you have also done ingress and egress out of the recovery site. So that actually concludes the presentation, essentially, and the demo.